All right, let's dive into something huge in the world of AI, causal reinforcement learning. We're going to explore how we can go beyond just teaching machines what to do and start teaching them to actually understand the why behind it all. This is a real game changer. So, you've seen AI do some absolutely incredible stuff, right? But have you ever just stopped and wondered why these super smart systems sometimes make mistakes that are, well, kind of dumb? It's like, what is going on under the hood that makes an AI so brilliant one second and then just completely lost the next? This isn't exactly a new problem. The philosopher David Hume basically nailed it centuries ago. He said that any real reasoning, I mean truly making sense of the world, is all built on understanding cause and effect. And that, right there, is the piece that's been missing from so many of our AI systems. So what's really going on here? It all comes down to something we can call the correlation trap. You see, traditional AI is an amazing pattern matcher, but sometimes, while it's looking for those patterns, it learns completely the wrong lesson. Okay, look at this. This is the perfect example of how simple this trap can be. Imagine you're training an AI on thousands of pictures of dogs. But what if most of those pictures just happen to show dogs on grass? The AI doesn't learn what a dog is. No, it learns a really bad shortcut. It learns grass equals dog. This is what we call a spurious correlation, a link that shows up in the data but is totally meaningless in the real world. And this exact problem, it's everywhere in standard reinforcement learning, or RL. An RL agent often learns just through brute force trial and error. It has no real understanding of the world. It just figures out which actions happen to lead to a reward. So what happens? It gets really good at one very specific situation, but if you change even a tiny detail, it's totally lost. It can't generalize because it never understood the rules in the first place. So how in the world do we fix this? Well, this is where a really powerful set of ideas comes to the rescue, all from the field of causal inference. Think of it like the missing piece of the puzzle. This is the toolkit that lets an AI finally stop just seeing patterns and start understanding the why behind them. The key tool in this new kit is something called a structural causal model, or SCM. Now, don't get hung up on the name. What's important is what it is. It's basically a map of cause and effect. It's like we're finally giving the AI the rulebook to the universe, showing it exactly what causes what. And this right here shows the huge mental shift we're talking about. On one side, you've got just observing the world. It's passive. It's like seeing that sailors who eat fruits seem to be healthier, but you don't really know why. But on the other side, you have intervention. This is when you step in and act. You make the sailors eat fruit to see the true effect. This is the difference between an AI that asks, what patterns have I seen, and one that asks, what will happen if I do this? It's a massive leap. This whole idea leads us to something called the ladder of causation. It's a framework for how we can think about intelligence. At the very bottom, the first rung, you have association. That's just seeing patterns. Then you climb to the second rung, intervention. That's actively doing things to see what happens. But the top, the highest level of understanding, is counterfactuals. This is the ability to imagine, to ask, what if I had done something different? That's where real intelligence kicks in. Okay, so this brings us to a concept that's basically a superpower for AI, causal factorization. Now, there's a formula on the screen, but don't worry about the mouth symbols. Here's what it means. It lets an AI look at a big, complicated, tangled-up world, and instead see it as a collection of simple, independent little cause and effect pieces. The big idea is that you can understand the whole system just by understanding each of its simple parts one by one. This is an absolute game changer for learning efficiently. Okay, so now that we have this amazing causal toolkit, let's get back to our original problem. How do we actually use this stuff to teach the AI to ignore the grass and see the dog? To find the true cause. The villain in this story is often a hidden enemy we call a confounder. A confounder is some factor that we're not even looking at, but it's the real cause of two other things we are looking at. For example, think about a medical study. If we see a new drug is linked to better health, is it the drug? Or could it be that wealthier patients who can afford the new drug also have better diets and access to better care? That wealth factor is the confounder, creating a false link that can totally mislead our AI. So how do we beat this hidden enemy? Well, causal inference gives us a clear three-step battle plan. First, you draw that causal map, the SCM, to see all the possible connections. Second, you find the backdoor path. That's the sneaky, fake route the confounder creates. And third, you use a clever statistical trick to block that path. The analogy is perfect. If you want to test a light switch, but the sun is also lighting up the room, you have to close the blinds first, right? You have to block the confounder, the sun, to see the true effect of the switch. That's exactly what we do with the data. Now, fixing these fake correlations is awesome, but believe me, that's just the tip of the iceberg. Once an AI can think causally, it unlocks a whole suite of new superpowers. We're talking about agents that can generalize to new situations, learn way faster with less data, actually explain why they made a decision, and even act more safely. Let's just zoom in on a couple of these for a second. Okay, let's talk about learning faster. Remember that top rung of the ladder, counterfactuals, the power of imagination? This is where it gets crazy powerful. A causal agent can literally imagine different outcomes. It can say, okay, I did this and that happened, but what would have happened if I'd done something else? It can then learn from that imagined experience without ever needing to actually do it. It's like having a built-in simulator, and it just massively speeds up the learning process. And then there's generalization, the ability to adapt. Because a causal agent understands the why, it isn't fooled by surface-level changes. A normal AI might completely freak out if you change the color of a character in a video game. But a causal AI, it knows the color of the character has nothing to do with how high it can jump. It understands the actual rules, the physics of its world, so it can adapt on the fly. It's the difference between being brittle and being truly robust.
Okay, this all sounds amazing, I know, but we gotta be real for a second. Causal RL is still a pretty new field, and there are definitely some big hurdles to clear on the road ahead.
For starters, creating that initial causal map often takes a ton of human know-how. And it's really, really hard for an AI to just look at raw pixels and figure out the underlying causal rules on its own. Plus, trying to scale this up to really complex, messy, real-world situations, well, that gets computationally expensive fast. And that awesome counterfactual stuff, it sometimes rests on big assumptions that are hard to prove. But even with all those challenges, causal reinforcement learning marks a huge shift in how we think about building smart machines. It leaves us with this really big question to ponder. Is the next AI revolution going to be powered by feeding it more and more data? Or will it come from finally giving it a true understanding of why? Something to think about. Thanks for joining me.